So that's what we were looking at a little bit ago. So that's the difference of squares formula that we've been using. And there's actually another formula for the sum or difference of cubes. So that's what I'm going to write down right now. I'll explain it a little bit, and then we'll actually see what it looks like with numbers. So I'm going to say difference or sum of cubes. So there's the keyword is I can have either a difference or a sum, meaning this for actually cubes is also an important keyword, and I'll show you what I mean by that. First, let's look at, since I wrote difference, let's look at a difference of cubes. Minus b cubed. So the reason this is a difference of cubes, difference because we have a minus here. Cubes because we have something cubed here. And this one will be a difference of cubes. The formula for this, and the way that I remember how to do it, is by first drawing parentheses. This is just how I remember, so I don't have to keep looking up the formula every single time I try these problems. I draw a small set of parentheses for 2 terms, and then I draw a larger set of parentheses for 3 terms. And what I'm going to put in here, just like I square rooted this, I square rooted a squared to get a. I'm going to cube root, and I'll show you how to do that on your calculator. I'm going to cube root a cubed to give me a, and I'll put that in front here. And I'll cube root b cubed, that'll give me b, and I'll put that there. I don't know if I said it correctly or not, but I'm cube rooting this to get regular a. I'm cube rooting this to get regular b. And then in the larger parentheses, it's larger, that's just the way that I remember. It's going to have a squared in it, so you're going to square this thing, put it in here, square this thing, put it at the very end. And then in the middle, there's some middle ground, you just multiply them both together. But there's symbols in between. And the way that I remember the symbols is by remembering SOAP. S-O-A-P. SOAP stands for same. So I'm thinking, what symbol goes here? SOAP means same as this. So that's a minus. O means opposite. And opposite of what? Opposite of that symbol. So that means we have a plus here. And then AP means always positive. So that one's going to be a positive there. Same, opposite, always positive. I'm going to run through that all over again, except for instead of a difference, I'm going to have a sum, but the SOAP method, the SOAP idea, or I guess acronym, still helps you write down the formula. So that was a difference of cubes. I'm going to say here is the sum of cubes, and I'll have something cubed, so a cubed plus, because we're doing the sum. No, you can't really see that. Plus b cubed, and once again, I set it up in the same exact way. Small parentheses for 2 terms, and then large parentheses for 3 terms. And just like I square rooted this, I'm cube rooting this to get a regular a. And I cube root b cubed to get regular b. Then I have a squared, b squared, and then both of them in the middle. AB. And once again, SOAP. What symbol goes here then? Yeah, it'd be plus because it's the same as this. What about this one? Subtraction. And the last one? Positive. So for the first example, we'll see. Let's do a sum of cubes so we can see. Still have our formula in the shot. Example 1. Factor completely. Our first step, still, just like on all the other factoring problems, our first step is to look to divide by a greatest common factor. So when I write this down, we're going to try and see a greatest common factor. So it's going to be x cubed, we'll say plus 27. So step 1, factor GCF, question mark. Can we factor out a greatest common factor? And in this case, we cannot. Do we understand that? You can't do it. So what we're going to do is we don't need to check. We don't need to check to see if this is minus anymore, like we did with the difference of squares. It can be either plus or minus, so it doesn't matter. What we do need to check is for cube rooting stuff. So the second thing is, can you, with a little 3 there, can you cube root both terms? And in this case, you will be able to. If I do the cube root, that's a 3. If I do the cube root of x cubed, that gives me just regular x. If I do the cube root of 27, and I want to show you on my calculator, it's this button. There is a cube root button. Can't really see it. Can you see it here? This is the square root. This is the cube root. So on your calculator, if you did 27 and cube root, that would be 3, because 3 times 3 times 3, you're using it 3 times, that gives you 27. So this would be regular 3 here. Then the last step is to follow same, opposite, always positive formula. And again, like without, I mean, the formula is up there, but the way I do it, so I don't have to keep looking back at this formula, the way I remember is, first, I write down my parentheses. One small one for 2 terms, one large one for 3 terms. And then here I cube rooted to get regular A. Well, I already wrote down what the cube root of my first term was. So I have regular x and regular 3 right there. And then whatever I get for A in the first spot in the large parentheses, I just square it. So what goes here? X squared. What do you think goes in the back? 3 squared, which is 9. Yeah? And then, yeah, you could write x times 3, but the more normal way to write it is with the coefficient in front. So we can say 3x. And then we look at SOAP. I don't normally write this down every time. I just look at this, find these, and then write my answer. But same as what? Same as this symbol. Same as the original sign in between. So same, opposite the original, always positive. And then this is maybe an X factor problem. So I guess the fourth thing is to check to factor further. I can't do anything to x plus 3. And then, let's see, can I do 9 and negative 3? That's only 1 and 9 and 3 and 3, and those both don't work. So that's it. So that doesn't work. And then we're all done. So on this, you're going to try on your own. I'm just going to mention, we did this type of thing before with square rooting. We square rooted the number and then square rooted the variable. We're going to do the same thing except for with cube rooting. So it's the same idea. And then the cube root of 1 is 1. So let's see if you guys can get that. I'm cube rooting both of these things, and I'm cube rooting the 1. So the cube root of 27, we just did that in the other example. That would be 3. The cube root of x cubed would be x. I don't put a symbol in here because I'm just trying to figure out the cube root part, because the symbol is not necessary. I only need to check the beginning. So there's no symbol in here. I'm just checking to see what the cube root is. Sorry about that. The cube root of 1 is just 1. You can do that in the calculator and see. And then I do small parentheses, larger parentheses. And then 3x1. And then I square this, which means I'm squaring both, because 3x times 3x, this is on the side, that's 9x squared. So 9x squared, 1 squared goes here, that's just 1. And then back to the original a times b, that's 3x. Same sign as this, opposite sign as this, always positive. And then you check, you can't do anything with 9 times 1 is 9, and negative 3, we already checked that stuff before, so this is the end. So the question was, wait a minute, you could do the x method or the super x after on this 3-term thing, on this trinomial? Sometimes, yes, and that's why the 4th step here is check to factor further, if you can. Most of the time you won't be able to, but you should check. And if you check afterwards, maybe you missed something to factor out in the beginning, and you were still able to do cube root stuff, you could still factor it out at the end and get the right answer. All right. Again, the instructions are to factor completely. What's the first step always? Yeah, see if we can factor out a GCF. So the first step is to factor out a GCF. That's always what we're looking for. And the GCF is 3 in this case, no variable. Whatever you divide by goes on the outside. And we have x cubed minus, is it 64? Y cubed. You do this the exact same way as what we did before. I'm going to let you try it from here. Except for the only thing that's different is the number that we had over here. Well, now it's with this term. But you still keep the same positions. If this stuff is first with no number, so that's going to be the first thing and the first thing. The thing with the number and the variable, that's going to go in the second places. And you're still going to multiply in there. So try that. So here we go again. We don't need to check for the inside here being plus or minus. It doesn't matter which one it is. We'll just use the SOAP acronym. We will cube root the x cubed to get regular x. We will cube root both of these to get, what's the cube root of 64 is 4. You can do that in the calculator. I'll show you once again. So I do 64 and then the cube root button. That gives me 4. So I have 4, and then I'm also cube rooting the y cubed to get just regular y. And then again I do small parentheses, larger parentheses, and I fill it in x for y, and then square this and put it in the front here. X squared, square this. Remember, that's the same thing as 4y times 4y, so it becomes 16y squared. And then multiply them both together. X times 4y is just 4xy. Same as this. Opposite sign as this. Always positive. And we're not going to be able to, we didn't look at doing a super x on this. This problem, no. But it would work the same way with the x's and y's. You just put a y in the second position. But we don't need to worry about that right now. That was, you're right. I didn't do this one. Same as this. Opposite. This should have been plus. Thank you. Plus. And then this one's always positive. Thank you. I think I said it and then just did the opposite. I missed something. What did I miss? Yeah. I need the 3. I need to carry the 3 along. So careful of that because I missed it. But same with this last one, which I didn't record, but don't forget to carry along what you factored out to begin with.